into the shop and talk about levers a little bit, but first I wanted to talk about a couple of vocabulary words that we're going to need to know. The first of those is called the load. And in physics, the load is whatever it is that you're picking up. It's the weight that you need to move, the object that you're moving, anything like that. So load is the weight to be moved. Effort is the force applied to something to then move it. So in simple machines, that's going to be a person pushing, pulling, doing something like that. So effort is the force applied to move something. A lever is a rod. So it's any rigid board, piece of metal, anything like that can be a lever. A rod that is supported by a balance point, and that point we call a fulcrum. And then a fulcrum, of course, is the balance point that a lever rests upon. So with those couple of vocabulary words, I think we can go down into the shop and we can get started. All right, guys, today we're talking about one of the simple machines, and this is a lever. So a lever is anything that is just a rod and a balancing point, which is called a fulcrum. So a lever is your basic seesaw from the playground. It's just a point where a rod can balance back and forth. All right, so there's three classes of levers. Now, I don't expect you to be able to say, walking down the street, I stop you in the street and say, hey, what's a class 2 lever? You don't need to know it to that degree. But if you understand that there's three different classes of levers, it helps you kind of figure out all the simple machines that are around you. So the first class of lever is where the fulcrum is between the lever and the load. It looks like this. And again, this is the basic seesaw that we were just looking at a minute ago. The effort is here. This is where a person would be pushing down. The load is here. This is whatever object is that you're lifting with this lever, or if it could be another person if that's a seesaw. And then the fulcrum here in the middle. So this is any class 1 lever. A class 2 lever has a load between the fulcrum and the effort. So it's a little bit different. You might be able to guess what this kind of simple machine would be from the picture here. Again, you have the effort on one end. This time you have the fulcrum on the far end and the load is in the middle. So think about that for a minute. You probably have seen one of these. Picture a person standing here, maybe with their hands right here on the rod, and see if you can't think of what that might be. All right, and then the class 3 lever is where the effort is between the fulcrum and the load. These you will find more often in the kitchen. Whoops, I have made a mess of my sign here. This is kind of an odd one where the effort's in the middle. The fulcrum is out here, usually where two rods come together, and then the load is between the rods. So you can find these in the kitchen, something like a nutcracker or a pair of tweezers. Let me step over here for a second. Here's a pair of tongs. This is a type of a class 3 lever where here's the fulcrum where the rods come together. The effort is going to be applied right here in the middle between the fulcrum and the load. And then the load is out here on the end. So if I'm picking up a marker, that is now the load. Here's the effort where I'm pinching with my fingers. And here's the fulcrum back here where they join. So this is a class 3 lever, which is a really handy tool, but you don't see it like out and about a whole lot. But tweezers, tongs, things like that would be class 3 levers. All right, so let's look at some class 1 levers. One of the most common class 1 levers that you might think about is when a hammer is being used as a crowbar, when you're using the claw part of the hammer here. When you're actually doing the hammering, that's a different kind of lever, so don't think of it that way. But if you need to pull a nail out of a piece of wood, you put it in the wrong place, you bent the nail, you are now using a class 1 lever. So here is the effort up top. Here's the fulcrum where it's in contact, and then here's the load, the nail that needs to be pulled. And then pull. Oh gosh, that's really hard to pull. So maybe the size of the lever makes a difference. What do you think if I go with this? It's a little bit smaller. Let's see if that makes it any easier to pull this nail out here. Oh, that worked, but hang on, that's not why it worked. It worked because I put a block of wood under here, because this would pull it up easily too. So there's that lever on a hammer wheel. Now I can get a really big lever, and that's going to pull that out with no effort at all. Were you back far enough to see that? Let me dry this. I'm going to use a new hole here so that we're not just loosening this up. So again, small lever. I can do it. I'm leaning my weight into this. There it goes. New hole again. I'm not putting any weight on that. Look how easy that came out. So the length of the lever makes a big difference. And the reason for that is it's leverage. This is what mechanical advantage is when we talk about simple machines. Mechanical advantage is when you are magnifying the force that is applied. So I still have my load down here, I still have my fulcrum down here, but then all of this is giving me a mechanical advantage when I apply the effort compared to this. Both are great tools. This makes it a lot easier than grabbing it with my fingers and trying to pull it out. But the bigger the lever, the more mechanical advantage you have. We're jumping back up into the office here just for a second to talk about what I was just saying in the shop. And if you notice that the small lever did the job, but I was having to work pretty hard to do that. The long lever, the long crowbar, was effortless. I mean, it just took no energy from me at all, no force from me at all to remove the nail using the long lever. So when we're talking about mechanical advantage, in simple machines, what's often happening is that we are trading distance for effort. So I can put in more distance for less effort. So let's back that clip up again and we'll watch that one more time. And you'll see that the top of the crowbar, the long crowbar, is moving a much greater distance than the little tiny crowbar. So I am having to travel my hand a greater distance, but I'm using much less effort. And you'll see that time and time again as we go through the different simple machines, that we are having to travel more distance, but it means that we need to apply less effort. That's the word I want, apply less effort. A couple other types of levers are a pair of scissors and a pair of pliers. And these are still class 1 levers because here you have the effort. This is where the force is being applied. Here you have the fulcrum. That's where the levers are intersecting. And notice that a lot of these levers are actually 2 levers intersecting on a fulcrum. And then here's the load down here where you would be cutting. Same thing for pliers, the exact same thing as the scissors. Here's the effort down here where I'm going to be squeezing. Here's the fulcrum where they come together. Here's where the load is when you're grabbing. Now the same kind of thing when you are using a lever, like when you're using the crowbar as a lever, but the same kind of thing. Which one of these do you think would be easier to take off a nut that was really stuck onto a bolt? And think about why it would be easier. I'm going to ask you that in an email soon. You're going to need to answer it. All right, thanks for watching. All right, we're back with our class 2 levers right here. Here's a wheelbarrow that is outside of my house for a project that we've been working on. So if we look down here at the wheelbarrow, this is our fulcrum point here where the weight is resting on the ground. That's the pivot point, right, for the rods. This is the effort point where the hands go on the wheelbarrow and we can lift it here. So this is our effort. You see how the fulcrum is pivoting down there on the axle of the wheels. And then of course the load is right here in the middle. So that's a class 2 lever. And that's the one I was showing you on the little whiteboard that I wanted you to see if you could guess. Okay, we're talking about class 3 levers for just a minute here. Here is a class 3 lever right here. My forearm is a class 3 lever. It works just like a hammer when a hammer is being a class 3 lever. So remember we said it's a class 1 lever when you're pulling a nail out with a claw end, but when you're using the business end of a hammer, it's a class 1 lever, and here's why. So here's the pivot point down here, the fulcrum. Here's the load way up high here. And then I am the effort that's taking place. So, hey guys, we're back up in the office. I was just editing the clip from yesterday about class 3 levers. And when I got to the part where I had this hammer in my hand, and I was saying that this is the load up here, and I said, I am the effort is back here, and the fulcrum is back here. And I'm using words that weren't very clear. So I wanted to be a little more clear than that. Let me back up a little bit so you can see a little better. So this is the load effort. This is the business end of the hammer. That's the load. That's what's doing the work that we're applying. The fulcrum is my wrist here. This is the pivot point that the lever is now working around. And then the effort is my hand that is doing the pounding with the hammer. So that's where the effort is being applied at my hand, but the fulcrum is here at my wrist, and then the load up top here. So a class 3 lever has the effort between the load and the fulcrum, which is my wrist. There we go, wrist. I'm looking at a camera and it's backwards. Well, all right, so that's why it was a class 3 lever. Thanks, and see you soon. The class 3 lever, the effort is between the fulcrum and the load. So here is the fulcrum, here is the load, the effort is back here with me, and that allows you to do a lot of work. Look how easy that is to put a nail in instead of trying to push a nail in this way. This allows that to happen. So that's a class 3 lever, and so is my forearm, just in the exact same way. It's a class 3 lever. All right, I just fixed a sprinkler line in the yard, and here I am using a class 1 lever again. Can you identify the fulcrum, where the effort's being applied, where the load is?
Okay.
Hey, here I am using a lever again. Do you remember which class of a lever this is? And where's the fulcrum? Where's the load? Where's the effort? Try to picture it.